Hello, today I'm going to go ahead and show you how to use Skanect to go ahead and not only scan a person or object and walk you through all the steps it is to remap the model to where you can go ahead and edit it or make it look better or change things a lot easier in Photoshop or picture editor program that you are using. The first steps that you do is you load up Skanect with a structure sensor loaded. Right now I do not have my Xbox 360 Kinect loaded. I'm going to go ahead and use a preloaded model. Under the new settings, basically I would select a body and then adjust the bounding box accordingly, and then also height times 2 since it's a person. Since I have already loaded this model, I'm going to skip that part and just load my dad, for example. And after he is loaded, you can actually check the different settings and everything for scanning. My settings, since I've got my desktop, I can record in high and also with my graphics processor. For offline recording or the reconstruct, you want to go ahead and select all frames, so that way it can do an offline reconstruction. The other options that they have listed are for tracking loss detection. Just say, for example, if your turntable or if you move the camera too fast and it can't pick up where it's left off, to go ahead and do the continual stitching. If you have tracking loss detection turned on, it'll say, hey, I've lost tracking here, move it back to the last point and we can pick up where we left off. If you have it to off, it just stops. The uplink mode is for the remote receptacle scanner, and you can go ahead and purchase that separately and check whether you want depth and color or as far as your gain and everything for recording. When you record, you'll have the automatic gain down here, you'll have the camera of like a webcam type here, you'll have the depth data, and then in here you'll actually see the section to where it's colorized for the depth in red, green, and blue. Red meaning you're too close, green meaning you're just right, and then blue means, hey, I'm a little far away, but yet I can still pick up the depth data. It does have a delay timer, so that way if you're actually set up to where you're scanning someone, you can go count down 3, 2, 1, 0 to go ahead and get in frame, or to go ahead and tell them to hold their position and don't move. I'm actually going to go ahead and do the reconstruction of this model, even though it's pretty much well here, just so that way you can see the reconstruction of the full camera, the depth part that you would see in that bottom giant square. This is a offline reconstruction. I hope it's not too slow, but this is in real time reconstruction on my graphics processor. And as soon as it gets to the point to where it's finished, you'll see that each of these little dots are each of a capturing of this whole process here. So now that it is done, we can go ahead and post-process it with several different options here. You've got a reset, which will reset it back to this exact part right here. Watertight actually does several different options. It actually goes ahead and fills the holes according to how you're wanting the holes filled, and does it in a watertight, which means it's solid. There's no gaps left open or anything like that, and how quality of a smoothing option you're wanting to do. So for example, if you're doing something like a ball or a abstract object, you may leave the smoothing high to where it does it a lot quicker. Of course, it also makes it really, really smooth. The lower the smoothing, the more detailed and defined the objects that you leave in there. Next option they have is external edit, so you can actually view it in Windows Explorer, edit the PLY file, and then you can reload it later to go ahead and load it back in here to go ahead and colorize it or to change parts and things like that. Simplify basically just takes the model and cuts down on the amount of polygons to where you can actually use it for 3D gaming, for 3D printing, and so forth. The next step, the next part after I go ahead and scan and have it ready, is I go ahead and fill the holes manually with water tightened very low, because I want to have a closed one for printing. That way I can use the model for printing, or if I can use it for video games or whatever later down the road. And then of course I want the best quality, so I do very low. And what that does is you'll see that there's a lot of holes right here that it didn't scan. Any of the undercuts, because I've actually got my Kinect pointing down a little bit, and it will go ahead and fill like behind the ears, behind the arms, and any other sections that it did not capture directly. It'll basically try and fill those in for you. Later down the road, I'm sure that they'll go ahead and incorporate a better way to go ahead and get you to be able to capture those underhangs, and to go ahead and fill those a lot better manually. I'm sorry this has taken a little while, but filling the holes on a model that is this huge does take a while. So I will pause that until it is finished. Now that it is finished, we're going to go to some of the other sections. As you can see, I've already got this rotated a little bit, but we're going to go ahead and do the move and crop. Anyway, for the next section, these actually are 3 different rotating procedures right here. This will rotate it in this manner. The other one will rotate it around this axis, and then the other one, of course, will rotate it in the other axis. I'm actually scanning on a round turntable, and this was my first test. I found out shiny glossy black is a no-no. It will not do well on that. This last one is actually for the height, so you can actually crop this to the ground, and basically what that'll do is this part right here that is added for the base of my turntable and everything that has been filled, which looks like blobs, we'll actually cut that to the ground, and what it's going to do is it's going to cut it on this blue plane here. So that'll be a flat base to be able to print on. Now if you move it down a little bit lower to where it's just the feet and everything, then that's probably the better idea for if you're going to try to take a model and rig it for a game, or for compositing into a backdrop or something of your own sort. The next section right here under geometry is remove parts, and basically what it does is if you've got a wall, or if you've got part of the ceiling that was scanned and it's got just little garbage outside, what it'll do is it'll remove all the garbage that's not part of the main model, and it does a pretty good job on that. The next section is basically whether or not you want color. You can colorize it, you can take out all the colors if you've already colorized it. In Paint is basically any section that it did not naturally capture that you've filled, it'll try and color those in as best as it can by taking the surrounding areas and blending them together. So I'm going to go ahead and pick the highest of the highest resolutions, so that way you can see how well it does. And also you will notice what it's going to do is it's going to increase all the polygons as well to go ahead and do the higher resolution. With the higher resolution, your texture maps look better, but yet your file size for your 3D model also gets bigger. For a standard 20,000 polygon model, you're looking at roughly less than 46 meg for a model. For a 2 million plus model, you're looking at about 230, 240 meg. So the next step after you've already got it done, and I understand it didn't fill right here, but it does a very decent job on the coloring. Um, just to let you know, this model right here, the reason why it's not graded in the face, but it is on the shirt and everything, is because I had 3 open bay windows behind him when it was scanning, so it got a lot of light into the camera. That you also want to take a look at when you're scanning a model. Next thing you can do is you can actually save the whole file to another folder on an external hard drive, somewhere else on another hard drive for archive purposes, or you can actually just export the model. I'm actually going to select this as an OBJ texture map, and then millimeters is what I'm going to use, the default section that you will have to remember, because I usually use millimeters for 3D printing and so forth. So as far as my scale units for this model right here, if I load it into a 3D printing that only has a 200 by 200 millimeter base, this is going to be way taller, as it recognizes it as the accurate height and measurements. For this tutorial's sake, I'm going to go ahead and leave it at the 20,000, although the 2 million would actually be a lot better texture. So I'm going to save this to my desktop as model, and then after it goes through and sets it to the right amount of faces, colorizes it, and makes the texture map, we will go on to the next part, which will be how to take the texture map from the Skanect, which, as you will see here in a little bit, the texture map is all over the place for all the little polygons, but that's okay, because we're going to go ahead and take them and move them to a front and back facing. Now that it's saving to disk and done, we will step over to part 2. Here's a picture of the model that I just took, and we're going to zoom in so that way you can see that it's done a pretty good job on the buttons and everything, as far as the head and so forth, but yet all the pieces and parts are pretty much well scattered everywhere, but yet they relate and map to a proper coordinate. The second program that I'm going to go to is called UVMapper Classic, and it's at UVMapper.com. It has not been updated since 2009, but the classic version, the free version, is what we're going to use for this tutorial here. The first thing we need to do is we need to load the model that we had saved. Again, I'm using the model we just saved of my dad, and we're going to go ahead and view it into here. As you can see, this is the same scattered, really hard to edit with Photoshop or any picture editing program. So what we're going to do is we're going to change it to a planar. You can actually change it or remap it however you want, but I actually change it to a planar with the y-axis, keep the scale result, and since my map was 4096, I'm going to leave it at 4096. What that's going to do is it's going to change it into a front-back mapping. Now that this is ready to save, just click OK and save it as remapped, or whatever you want to remap it as. Now the sad thing about it is this does not transfer the color map over at all. This just basically saves the remapped OBJ file, and we're going to show you how to remap all that real easy and add the colors back in another free program called Meshlab. Now that we have Meshlab open, what we're going to do is we're going to import the meshes. And by the way, Meshlab is a free program to use. we're going to load both models, the original model. As you can see, it actually does have the full texture map that is, even though it's jumbled, it still loads it according to each vertex and everything. So we're going to also import the remapped version, which does not have a texture map loaded at all. As you can see, it says, hey, we're going to load a white one because we don't have a texture map. That's okay. So as you can see, you've got both models loaded on top of each other. Here is your remapped model versus the colorized one. So in order to go ahead and take the color from the original model to the remapped, we're going to go into filters and then under texture. Then we're going to go ahead and change the texture to a vertex color between two meshes. So we're going to select the original model, and our target's going to be the remapped model. Once we hit apply, what that's going to do is it's going to take the original model and it's going to project all the colors and everything onto the remapped model. So when we hide the original model, you can see it's actually colorized now. So the next step we're going to do is we're going to delete the original model out of Meshlab, not from the hard drive, and we're going to go back into filters under texture, and we're going to take a snapshot of the new colorized texture map. Now be wary that when this goes ahead and exports this new texture map, the colors and everything are not going to be right. It's going to go ahead and export a colorized version that may be missing data because of the projection, but it'll give you a good example to go ahead and paint with instead of using that black and white wire map that I forgot to show you how to export that template, and we will get back to that here in a second. But once you apply it and save it, your remapped model will actually be in the same folder as your files that you just loaded. Another thing you can do is you can go ahead and export this mesh back after you set the texture. To do that, you can go into filters, texture, and then we go ahead and hit set texture, and we're going to leave that as the same file as before and apply it, and that just applied the texture map that we exported straight to it. And now we're going to file and export the mesh as, if you want to, you can override it or you can change it to another one. I'm just going to override it as the remapped model to begin with. What it will do is it'll ask you, do you want your texture name? I'll just click OK, and then basically you have your remapped OBJ file. You've got the way it's been changed and everything, and you're ready to go for your painting and 3D modeling and so forth. And as you can see, this is the original map again, and this is the remapped one. Again, it's not perfect on showing you the colorized one because it is an old program, but it's better than painting on the template. Since we're getting back to that, the template feature inside the UVMapper Classic, you can hit File and save the texture map when you go ahead and remap it, And what that'll do is that'll let you save a template, which is the wireframe part that you can paint on. Or you can actually go back to the picture and everything and just paste the front of the face, the back of the head, and so forth back onto the picture that you've already got. I realize that this is not the best example to use. I have actually exported a lot better ones with this process, and this map looks a lot better. I found out how to do this all through Google. I hope you have a good time, and I hope this has helped.